For the technique we're going to use on this integral, we're going to need to review the practice of completing the square. This is where we take a polynomial, a second order one, and basically set it up in order to make it into a perfect square, where we have just the same factor in each case. This is a classic example of a perfect square. All I've done is factor this out and it becomes x plus 3 times x plus 3, which is x plus 3 squared. Completing the square comes in, what if we had an example like this, where I do not have a perfect square and I do not have something I can factor out. The objective here is for me to get this and to make it look a little more like this so that I can factor it out quite nicely. So I happen to notice this 11 right here is simply 2 more than this 9 right here. So what it strikes me is that this is equivalent to x squared plus 6x plus 9 plus an extra 2 right there. This right here I already know is equivalent to x plus 3 squared. So I can express this as x plus 3 squared plus 2 in order to get this into a more workable form. This is the technique of completing the square. We're going to remember that for an upcoming integral we're about to work.